Let's discuss Unit 6 solutions, an observational technique that can be used to understand operational process and help to derive requirement for software to support operational process is known as. What is requirement specification? It is actually the collection of all requirements that are necessary for design, verification, and even maintenance of product. So in short, we can mention collection of requirements. This does not talk about observational technique. Next is structural specification. In short, we can say it is about architectural design. That is how a software system is to be developed in order to achieve the goals that are specified in the requirements. Next is ethnography. I think you could have come across this term, ethnographic research. It is actually done by way of observation. So this is the observational technique. Now we can map it. Ethnography is an observational technique that can be used to understand operational process and help to derive requirement for software to support operational process. So ethnography will be the right answer because this is the only observation technique out of these four. Then what is natural language specification? From the word natural language, we can understand it is the normal plain text that we use. So it's a way of writing requirements in normal plain text. This is natural language specification. Next question. Which of the following is used to determine the cost performance index? In short, we can call it as CPI. So what is cost performance index? It's a method to calculate cost efficiency and financial effectiveness of specific formula. So CPI is given by the formula earned value divided by actual cost. There are three conditions here. If the CPI value is less than 1, it means the project is over budget. They might have allocated some amount as the budget and the project is going beyond that. When the value is equal to 1, it means project is on budget. And when the value is greater than 1, it means project under budget. So here they have given budgeted cost of work performed and budgeted completion, then actual cost of work performed. So keeping this term actual cost in mind, we are removing option 1 and option 2. Earned value is written as budgeted cost of work performed. Now we look at the operator here. It is divided by. So here it is subtraction. We will rule out even fourth option. Option number 3. CPI is given by the formula budgeted cost of work performed divided by actual cost of work performed. So this is budgeted cost divided by actual cost. Next question. Which is intended to show that a system both conforms to its specifications and meets the expectations of the system customer. What is software specification? It is the specification of requirements. SRS document usually lists that. The software requirement specification document usually carries that. What is software design? It is about transforming the requirements to some other form. So we will do coding and other kinds of implementation in order to transform the requirements to some product or to some form. What is software evaluation? This is done in order to detect dysfunctional and unused software. Usually some parts of the software might not be used and this process will detect that. When all these three don't go with the statement above, we can obviously know option 4 software validation will be the right answer. So what is software validation? This will check if the software has met the client expectation as well as whether it has met all the specifications mentioned in the requirements. So software validation will be the right answer. Next question. The following table shows the time between failures for a software. Time between failures, TBF. The error number is given. So there are totally 5 number of errors. and the time since last failure in hours has been given. The reliability of the system for 1 hour operation assuming an exponential model is, we have reliability of time is equal to e power minus t divided by mtbf. So everything is in the power only. T is the time actually. Here this is T. For 1 hour operation, T is equal to 1. What is MTBF? Mean time between failure. The time between failures have been given. TBF. Mean time means you have to sum up all the time between failures and then divided by number of failures. So here the number of errors. So mean time between failure will be 6 plus 4 plus 8 plus 5 plus 6. I am taking all the time and summing it up, divided by the number of errors or the number of failures will be totally 5. This is just the count. This is first one, this is second one, this is the count. So there are totally 5. 1, 2, 3, 4 and 5. 6 plus 4, 10, 10 plus 8, 18 plus 5, 23 plus 6, it is 29 divided by 5. Now reliability for 1 hour operation is equal to e power minus 1 divided by 29 by 5. When I have something as fraction in the denominator, I place the fractions denominator in the numerator. So this will be e power minus 5 by 29. Option 3 will be the right answer. So the time between failures have been given. You are just calculating the average of it and applying it in the reliability formula. Next question. Consider a popular sports news site. At a given moment, 20,000 concurrent users submit a request, a transaction T, once every 2 minutes on average. Each transaction requires the web app to download a new article that on average it has 3K bytes in length. What is the throughput? This comes under web app testing. It's to uncover errors in the web app. Uncover errors in the web app's content, function, usability, performance, security, etc. So I am just giving in short as web app. There is something called load testing. Load testing is about how the app is going to respond to various loading conditions. Now they have given number of concurrent users to be 20,000. So this will be denoted by capital N. N is equal to 20,000. Then we have the number of transactions per unit time. That will be denoted by T. So T is equal to once every 2 minutes. So this can be written as 1 by 2. Out of 2 minutes I get 1. Here the throughput is given in second. So here it is 1 by 2 minutes. So what we will do is we will change into seconds. So 1 by 2 into 60 seconds. We are not bringing seconds to the numerator. We are just keeping it in denominator. This is equal to T. Next we have the data load processed per transaction. The data load will be represented by capital D. Here they say the transaction requires the web app to download a new article. This will be the data and the size of the article will be 3K bytes in length. 3K bytes. They are asking for the throughput. The formula for the throughput P will be capital N into T into D. 20,000 into 1 divided by 2 into 60 seconds into data is 3K bytes. So here I can cancel 2 and 2. We have 3 into 10,000, 30,000 divided by 60. Now K bytes will stay and this seconds will go up per second. Now cancelling this I have 500. So the value here will be 500 kilobytes per second. Now the answer is given in megabits. So we have to convert it. 500 KB per second is equal to 500 into, this K can be written as 2 power 10. So 1k is equal to 2 power 10. 1m mega is equal to 2 power 20. Instead of this bytes, 1 byte is equal to 8 bits. I'm just converting into 8 bits per second. Now this is 500. How can I express 500 in terms of 2 power? So 2 power 10 is 1024. Then 2 power 9 will be 512. So this is approximately equivalent to 500. So I am expressing this in the form of 2 power 9 into 2 power 10 for the kilo. Then into 8 can be expressed as 2 power 3 here. So it is 2 power 3 bits per second. I have converted the byte to bit. That's why I have mentioned here bits per second. From this I am taking 2 power 9, 2 power 10 into 2 into 2 power 2. 2 power 3 can be written as 2 power 1 into 2 power 2. Now combining these two, I can say it is 2 power 10 into 2 power 10 into 2 power 2. So altogether we will have 22, which means 2 power 20 into 2 power 2. 2 power 2 is equal to 4. So I have 4. 2 power 20 is m, and here it is bits per second. So it is 4 megabits per second. This answer is matching in option number 2. Option number 2, 4 megabits per second will be the right answer. Actually the calculation is over here, but you need to convert into the form in which the option is given. That's why we are doing this set of calculation. Next question. Consider the following statements about the software product line system. In advanced software engineering, there is a concept called product line system or the software product line system. Only in advanced software engineering books you can find this topic. There are two statements given. At the interaction level, components provide an operator display interface and an interface with the communication system used. Statement 2. At the I/O management level, components handle operator authentication, report generator and query manager. Now we'll just know what is software product line. This is a set of software intensive systems that share common managed set of features satisfying a particular market's need. Actually, it is developed from a common set of core assets. These assets can be components, framework, library, a tool, development or execution platform. The assets can be any of these. So they have given a list of components. The statement 1. The components provide an operator display interface and it is responsible for interaction at next level. It is up to this and then we continue. And the second point, a point of connection with many communication methods are employed. The second point is the second half of the first statement, interface with the communication system used. So this is at the interaction level. Statement 1 is obviously true. And next, components handle operator authentication located at level 2 I/O management. So at the I/O management level, they handle operator authentication is also present. I could fetch only these many points. If you have any idea about advanced software engineering books, you can just go through for some more details. So this statement is also true. Keeping these points under consideration, we are marking option 1. Both statement 1 and statement 2 are correct to be the right answer. Next question. Given below are two statements. One is labeled as assertion and the other is labeled as reason. Assertion states validity checks real need of system users. Validity is used to check whether the system is performing the functions proposed by the users. Assertion is actually true. This checks the real need of system users. The reason. Completeness checks system user defined requirements. This is also true. What kind of requirements are these? Requirements cover all aspects of the system. It can be functionality, performance, reliability, security and usability. All the aspects of system are covered in this requirements. So completeness will check system user defined requirements. In the light of above statements, choose the correct answer from the options given below. We know that both A and R are true, so option 3 and option 4 are removed. Do you think completeness is going to be a reason for validity? It is obviously not. R is not the explanation of A. Validity is checking about the needs of the user. It's about the function that the system has to do. Completeness is about covering the overall aspects of system. Actually, functionality will be one of the aspects that is taken care of validity. The rest, like performance, reliability, security, and usability, should also be covered in this requirements list. So, taking this point, we say that option 1 is also wrong. Option 2, both A and R are true, but R is not the correct explanation of A because only one aspect functionality is checked by validity. Completeness is checking all aspects of the system. Next question, given below are two statements. Statement 1, subsystem models show logical grouping of object into coherent subsystem. Statement 2, state machine models show how objects change their states in response to events. We have a topic called UML design models. It is divided into two types broadly. One is structural model. The other one is dynamic models. Structural model is actually static in nature. It specifies about the object classes and their relationships. As the name goes, dynamic models are dynamic in nature and it shows or it depicts the interaction between the system objects. Under dynamic models, we have sequence models. The sequence of object interactions represented using the UML sequence diagram or collaboration diagram. The second model will be state machine models. The state machine models show how objects change their states in response to events. This will be the right definition. And it is represented using state diagrams. These diagrams are high level models of a system or the object's runtime behavior. So state machine model statement is true. Now let's check the first statement. Subsystem models are represented using a form of class diagram with each subsystem shown as package with enclosed objects. And this subsystem models will be static structural models. Grouping of objects into coherent subsystem is what they mention as package with enclosed objects. So statement 1 is also true. Option number 1, statement 1 and statement 2 are correct will be the right answer. Next question, consider the following statements and they are asking us to choose the correct answer from the options given below. Dynamic metrics are collected by measurements made of a program in execution. This is true. Why are they collected? To measure what? This is to assess efficiency and reliability. Static metrics are collected by measurements made of representations of the system. This is also true. This is used to assess complexity, understandability, and maintainability. A and B together we have only two options. So we will remove these two. The assessment of software quality is an objective process. Software quality involves partial or complete code review, architecture review, testing, and it has to assess a software product's compliance with development standards. Software quality assessment is done to find defect in the software product. So assessment is not an objective process. We are marking C to be false. The next statement, an important part of quality assurance in the selection of standards that should apply to the software development process. Usually, when we assess a software product, it has to be in compliance with the development standards. So, the important part will be in the selection of those standards only. This statement is also true. Option 1 is also ruled out. Option number 4, A, B, and D will be the right answer. Next question, match list 1 with list 2. 4 types of testing are given. What is scenario testing? Scenario testing is the documentation of a use case. The meaning is perfectly mapping in fourth option. So we will rule out second one and fourth one. Next is regression testing. It is a testing that runs after every change that we make to ensure that the change introduces no unintended breaks. Because of changing something in the program, it should not develop new bugs or new errors in the system. For that purpose, we go with regression testing. So here the third option, no new bugs after changes in program, is perfectly right for regression testing. B is mapping to 3. Next we will check for component testing. Component testing is also known as program testing or module testing, and this is done after unit testing. The objects can be tested independently as a component without integrating with other components. So option number 1, to verify the input output behavior of test object. C will be mapping to 1. Option 3 has C mapping to 1. So we will rule out even option 1. Option number 3 will be the right answer. Next is beta testing. Beta testing is also called as user acceptance testing, and real users perform this testing. So beta testing will be mapping to user acceptance methodology. D is mapping to 2. So option 3 will be the right answer. With this we are completing unit 6 questions.